All right, we're just about to get started with Allan Friedman's talk. I'm going to introduce him 1 minute early so he gets the full time. He's the Director of Cybersecurity at the National Telecommunications and Information Administration in the U.S. Department of Commerce. He coordinates NTIA's work on cybersecurity, focusing on building communities of passionate experts to address vulnerabilities across the software world. He's going to give his talk. You can submit questions to the sli.do. And he will moderate those and answer those at the end of his talk. Thanks.
Thank you so much. Thank you, everyone, for joining us. I'm a failed professor who got suckered into joining government about 5 years ago. In the last 5 years, we've tried to tackle some of the fun and sticky issues in InfoSec where the government doesn't say, we want this as a solution, but there is a clear interest in having a solution out there. And so what we've tried to do is bring together the experts in the world who know about this stuff to say what will actually work for us. So security is about unpredictability. You're having a fine one afternoon, and then all of a sudden, Katz comes up to you. No, he doesn't say your base will belong to us. He says, we've discovered a new vulnerability, right? This happens all the time, and sometimes it's in the top-level software that you know about that's in your vulnerability management system, but more often than not, it is going to be in a component that's going to be a little under the water level. It's going to be used as a third-party approach. So, do you have a chance to survive? Can you make your time? I would argue that today, there are very few organizations that can quickly and easily answer this question. That can actually say, when they learn about a new vulnerability in an open source library, whether you make software or use software, there are very few organizations that can say, we are affected or we're not affected. And if we are affected, here's what we can do. And so our vision here is to actually tell the story about how transparency can drive that resiliency, that ability to say when we learn about these new risks, we can adapt and respond properly. So transparency in the marketplace is not a new issue, right? We are used to a world with lists of ingredients. And it's kind of crazy that we know more about what's in, say, a box of Twinkies than we do about what's in the software that's running our entire world. And even, by the way, that's important. Fun fact for those who didn't know this, Twinkies not actually vegetarian. Now, what's really important to remember is most of the time, some of us may not care until there's someone in your life that's got a food sensitivity, that has a religious restriction, that has a way of life, and then it's very important that that data is available and accessible in a way that you can use it. And that's the vision of transparency. It's not about forcing particular behavior. It's about empowering good risk-based decisions based on your own needs. And this isn't unique to the consumer space, right? So if you are in the chemical world, there's something called a safety data sheet. If you run a factory, you get a pallet of 50-gallon drums. Each of those is going to come with a safety data sheet. It's an ISO standard that says, this is what's in the barrel, and this is what you do when it upends all over Frank, so that you know what to do with Frank when he's covered in the chemicals. And even the term bill of materials comes from industry. It's a very old term from the software supply chain, or from the supply chain world, which says if you go and buy a 10-ton diesel generator for your facility today, right? That's resiliency. That's making sure you know what to do when the power goes out. It will come with a bill of materials. Here's a list of every nut and every bolt so that you know what the total cost of ownership is, so that you can do maintenance on it. But today, if you buy it, it's going to be connected to the internet. And I would argue that unfortunately today, you have no idea whether that IP stack is made of the freshest, healthiest ingredients, or it's going to do things that are damaging to you and yours. So why should we think about this for software? Well, because I would argue for software, knowing what's under the hood is even more important, and it's more opaque. So here's a great project that a woman named Asako-san at NTT has done, where she sort of said, hey, we have a single manufacturer. It's rebranded by a bunch of white box vendors. How do you know what the firmware, what the vulnerabilities in your IP camera are? And these aren't the cheap ones. These are the commercial grade cameras. So this is, you buy it, it comes from vendor. You have to use a project like this before you can even find out whether there's a vulnerability. Hint, there are several very real vulnerabilities in this exact camera, one of which, in fact, was a key driver behind the Mirai botnet attack that took down Dyn. But of course, software doesn't just run cameras, doesn't just run organizations. It runs large pieces of equipment that go boom, and it runs small pieces of software that are about as important as they can be, literally a matter of life and death. So as we think about understanding the software supply chain, it's important to remember that we can wear different hats. I like to wear hats. And it can really, transparency can drive real benefits based on if you make software, you choose software, or you're operating software. So if you're making software, again, first of all, you gotta know what you ship. This is something that surprisingly few organizations were doing even just a few years ago. More of us are now aware of it, but it's something that we're still trying to learn how to do better, of monitoring for vulnerabilities. But even just, you look at what's under the hood in some of these large products. There's some vendors that will ship a large product with 4, 5, 6, 7, I've heard 9 versions of the same piece of software inside one blinking box that's used in critical infrastructure. So it's not just about security. We can tell a story about quality as well. Now, if you're buying software, it seems to me that a very important question to ask is, hey, are you selling me something that out of the box will put me and my network at risk? So this is something where we're going for, where we're trying to say, here are some of the questions that we can ask today. Or alternatively, you can say, hey, you're giving me some software. What do I know about it and what don't I know about it so that I can do a more secure, a more targeted security analysis? And then finally, of course, operating software. I've got something on my network, a new vulnerability is announced. Am I affected? Is one of those core questions that we need to ask ourselves. But almost as important is that last bullet, which is if I'm affected and I'm waiting around for my vendor to respond, if I know that I'm potentially at risk, I can take risk-based decisions of my own. I can tune my IDS. I can segment my network. I can take decisions that I think are the right level of precaution based on the software in question, my network, what's exposed, et cetera, et cetera. So why aren't we doing this already? Right? This sounds like a pretty good idea. We do it in other areas. Why aren't we doing it already? Well, one answer is those pesky lawyers. Software licensing is a challenge. Until a few years ago, I don't know how many of even the biggest companies in the world could honestly say that we know we've got all of our licenses sorted and we're not shipping any GPL products or anything like that. I think that in 2020, that's a much better understood risk. There are more and more tools on the market that can do this kind of analysis for you, turnkey. This is something that lawyers are aware of. This is something that we have a better handle on today. Another reason is that it turns out it's actually a little bit hard. Because for this to work, for this to scale, we have to have a shared vision across the entire ecosystem. And we don't have that, or didn't have that until recently. And we didn't have it because it was a little bit of a chicken and egg problem, right? No one was asking for this information, so no one was providing it. No one was providing it, so no one was asking for it, so there were no tools to use it. Now, that is what we economists like to call a market failure. And market failures mean that your friends, the government, get to get involved, right? Who doesn't love it when the government just shows up? Now, how does the government traditionally solve problems? Well, we can either pay you to do things or beat you until you do it well. And unfortunately, no one gave me a budget or staff, so I can't pay anyone to do anything. And either unfortunately or fortunately, Congress did not see fit to empower me to do jack shit. So I can't tell anyone to do anything in any meaningful way. So the solution that we have is we bring a bunch of people together and I say, I'll go away if you all solve this problem. And our vision here has been pretty ambitious. Because for this to work, it has to apply across every vector. If we go and say, here's a solution for the people who buy and build for DoD land, and here's another solution for this regulated sector, and finance is going to go off and do it one way, well, that won't work because that won't scale, and it means we won't get the benefits of tooling and mass adoption. And we also have to look at the entire software lifecycle. Open source, middleware, commercial software, embedded systems, and perhaps most importantly, the end customer. So we're trying to make sure this is market-driven. We want all those perspectives at the table. So we have this lovely thing that we call the multi-stakeholder process at NTIA. And if you roll your eyes at the term multi-stakeholder process, I'm the guy who has to say it like 8 times a day. But it's the term that we're saddled with. And so what we've done is we've tried to bring folks together. And just very quickly, to assure any skeptics or people who are afraid, what are we not doing? It's not regulation. Again, we're not empowered to do anything, although I'll touch back on regulation a little bit later. It's not source code disclosure. It's not standards development. We're not a standards development process. And we're not trying to solve everything in supply chain. Supply chain's a big enough buzzword that you too can have your own federal government process based on whatever you want to do. We're not trying to solve everything. We're looking at this one key area, which is the thin, narrow level of software transparency, in a way that is lightweight and is meant to scale for all software. We've been doing this for a little over a year. I'm very pleased to see that a few of you in the audience, lying, I can't actually see anyone in the audience right now, but some of you in the audience have been participating, and I think we've made a lot of progress. What have we done? We have a shared vision of the scope of the problem. We've developed some baseline definitions, an emphasis on the fact that it's got to be automated, it's got to have this broad scope. And on this handy-dandy website, which is also going to be on some of these stickers that we'll give out, you can see some of these resources. We've sort of defined what is an SBOM, why we should SBOM, how do we SBOM, and then can we SBOM today? And we're still working on now the next step. So very briefly, Allan, you've been talking about an SBOM for a long time. What the heck is it? Well, here's a toy example of what it can look like. I've got my Acme appliance. And it uses 2 software components, uses exactly 2. We know what they are. And in turn, Bob's browser, we know, uses Carol's compression engine. Carol's compression engine, we know. So the other thing, in addition to having a tree here, so we know what the relationships are, which can go as deep as we want, the other thing we're capturing is known unknowns, so that when you look at this, you have some idea of the completeness of information. So we know that Acme Appliance has exactly 2 dependencies. We have no idea whether Bingo Buffer has any dependencies or not. We know that Carol's compression engine has no dependencies. It's a root in our tree or a leaf in our tree, depending on which way you draw your tree. Believe it or not, it took many weeks to figure out which way we should draw our tree. Do you put the root at the top or the bottom? Turns out, as long as you need one way to do it, standards are hard. Who knew? And we know that Bob's browser includes at least Carol's compression engine. It may include more. So you can look at this and get some idea, not just what you have on your network, but if you really need to know what's on your network, you now know where to do further research or where to start asking questions. So now, each of those, when I say here are the components, what do we mean by a component? I want to be able to sufficiently uniquely identify each component. So what's the supplier? What's the component name? What version is it? Right? I need to know whether it's up to date. And then, by the way, give me the hash, so that I can verify that you and I are talking about the same one. I want to make sure that you didn't just go download some cloned, backdoored copy on GitHub. So we've got our tree, we've got our components. How many levels deep should this tree go, Allan? As deep as possible. We want as much information as we can, but we also acknowledge that it's going to be hard to do at the beginning. And so the minimum viable approach is you need to have at all of your top level includes. Tell me what they are. And again, when I say includes, we're talking about third-party code. Not the code that you write, but what are the components that you're bringing on board. And then, ideally, in a magical world, if everyone does that, we will recurse our way all the way up the supply chain. And by the way, if we're in an open source world, then if someone really cares, they can take on a lot of that ownership themselves. So, I've talked a little bit about the benefits, but I want to flag 2 more systematic benefits that sort of capture some of the public policy interests here. One is just thinking about how having this kind of transparency will help us when we do discover something that's far up the supply chain. So at the top here, we have a traditional case of timed remediation once we find a flaw, which is I find a flaw, we manage to convince the maintainers of that open source project, and so they go and fix it. Takes them some time. And then they put that patch out, so the people who are using it say, oh, look, there's a new version of this. Let's try to integrate that. So it's got a cascade all the way down in what we might use, the analogy here is a waterfall. Everyone knows that waterfall is the best way to develop software, right? This is the analogy that we still love to run with. So in a world where we have transparency, the software doesn't magically fix itself. I don't want to overstate it. But while you're waiting for that improvement, for the fix to slowly percolate down, you can be prepared. You can make a decision, again, based on your risk and your needs to say, we're going to put in something in line that will at least make us more comfortable thinking about our risk days. So the other thing that I like is this has a real potential to have some changes in the open source ecosystem itself, where we can start to create some market-driven pressure from downstream users to say, hey, let's think about what open source libraries we should use. And I don't want to pick on open source. Commercial is the same way. Which ones we want to use. Because now I know that my downstream customers and their customers have a chance to look at me and ask why certain decisions were made. So a couple of great stories here. I'm sure some of you have heard the story of you have a choice between two projects. One has never had any security issues whatsoever reported. They've got no CVEs. The other, in the last year, had 2 public CVEs reported against them. Which one do you pick? It depends is the right answer. But I would argue that having a CVE against a software project is actually a good sign. It means that they are aware of security issues, they're willing to fix them, they know how to fix them, and they're aware that fixing security issues involves a broader ecosystem initiative than just fixing their own code. So, I'm not going to delve too strongly into how do we do it. I can just say that we've gotten pretty close to solving this approach. We didn't want to invent a new standard. The good news was at least one technical standard out there said, hey, we can capture SBOM data. The bad news is that more than one technical standard out there said, hey, we can capture SBOM data. So our vision was to make sure that we can reconcile these two. SPDX comes out of Linux Foundation. It's a way of capturing open source data. It was built to address licensing issues, but we can use it for our interests in security. SWID, or software ID tags, is an ISO standard. That's great news if you work for a company that wants to trade around the world. It's a little frustrating if you want to actually read the spec yourself and you don't have 390 Swiss francs handy. But the good news is you can go online and look at NIST 8060, which sort of details, here's some of the spec, here's what are the fields that we should care about behind SWID tags. And again, our vision here had been to make sure that we can have bilingual translation. And in fact, there's a third standard called Cyclone DX that's being developed in OWASP specifically for the online application needs. So we also, in the past year, there was a proof of concept from the healthcare sector. Remember I said, we're not regulatory. I don't have any power. But we've got friends with power. And the Food and Drug Administration, which regulates medical devices, has publicly said, we're going to require every new medical device that wants to come onto the market to have an SBOM. Well, regulation got the attention of the healthcare sector, and so they went off and said, we're going to show that we can actually generate this today. That the medical device manufacturers can generate the data, and hospitals, including some of the best hospitals in America, New York Presby, Cedars-Sinai, Mayo Clinic, were able to use that data against predefined risk-based use cases. Asset management, vulnerability management, pre-purchase risk decision-making. That's the good news. They were able to do it. The bad news is that without taking advantage of all the work that I've just described, no one was able to do it in a completely automated fashion. And so that's really where we're pivoting for our next steps. This process is ongoing. We're continuing to refine and extend the model. I'm going to talk to you about a few of these challenges around namespace. But we're also trying to collect tooling. This is not just open source. I know that there are a number of companies out there today that are working to solve this exact problem for you. That's great. I'm from the Department of Commerce. My agency believes in the power of people making money, especially when they're providing a valuable good or service. So that's what we're trying to do, is capture as much of this as we can about what's out there today. And then, of course, awareness and adoption. That's where a lot of you come in. How do we get this message out? What are the benefits? How can this help your corner of the security world? And by the way, would you like to do a demonstration? Would you like to do a proof of concept? We have a bunch of them ongoing. This is your chance to roll up your sleeves and actually build something. There are a few challenges we're trying to tackle very briefly. Naming software is a known hard problem. I would argue that in the history of IT over the last 40 years, we've successfully solved the decentralized global namespace problem exactly once. And the annual budget of ICANN is about $140 million. So we're not going to recreate DNS, but we can make some progress. We're trying to figure out how do we do this in a way that is neither centralized nor requires everyone to change what they're doing, because that's easy, right? A lot of the solutions are, oh, this is super easy. Everyone just do what I do, and then we'll all have the same model. How do we share SBOM data? This is, again, we need to make sure that it's getting into the hands of people who need it. The vision here is not to say that there's one way to do it. It's to say, here's a small set of ways this problem can be solved. Pick one that works for you. One of the core challenges that a lot of folks, especially on the vendor side, are aware of is they said, hey, just because something's vulnerable doesn't mean that it's exploitable, right? I'm using OpenSSL 0.9, but guess what? It's for a client-side piece of software. So by definition, it cannot be heartbleedable. Please turn off the blinking light on your dashboard. How do we allow that kind of communication to happen down the supply chain in a way that means that we can start to pay attention and focus on what's really important? And of course, I mentioned the opportunity for a proof of concept, where since we have all this information out there today, could you actually show that this could work for your organization? Or whether you build software, or whether you're buying software, or somewhere in the middle, what could help you, and what is the type of information that you need? So, taking a step back, transparency is part of the nutritious breakfast that is going to be addressing the entire issue of security in the supply chain, right? It's messy, there's a lot of stuff there. But transparency is going to be the foundation for thinking about it. There are a lot of different solutions out there to improve on this, but they all start with making sure that we know what's actually under the hood of our software. So I have, I think, 3 minutes left for questions. You can use your app. I'm going to please get in touch with me. That's my email address. If you send me a note saying you want to join, I'll give you a sticker. If you tweet with the hashtag SBOM, I'll give you a sticker. If you ask the question, I'll give you a sticker. If you come up to me and say hi, I'll give you a sticker. So let's see. Does SBOM scope include hardware and firmware? So on firmware, I would much rather debate which of our text editors is the superior in an objective fashion than talk about the difference between software and firmware. What I will say is for firmware, did you write it? If you wrote it, then it's your software. It's not third-party components. If you're using third-party code in your firmware, then that's something that you probably need to be aware of and be able to track that. Hardware is a different problem. In some ways, it's easier, especially at the sort of end of high-end chips. In some ways, it's a lot harder, especially as you move down the supply chain into hardware, because a DIM is a DIM is a DIM. You're looking at it from a manufacturer perspective, and you're saying this is just a SKU. So we're trying to just focus on the software side of things. So let's see. I have there's a question which is an SBOM a tree or a directed acyclic graph? That is a great question. We will leave that as an exercise to the reader. So there's another great question, which is, hey, couldn't some source code repository products, like say GitHub or Bitbucket, think about this and try to solve this for the entire ecosystem? That's a phenomenal idea. I've had the opportunity to work with a number of folks from GitHub that are very interested in this. GitHub will do some of this for you today. They will flag your dependencies that are risky. So we're starting on this. The challenge is, of course, while that gets us a lot of the way, it doesn't get us all the way there, especially when we're thinking about commercial software. Commercial software running on your network is sort of quite the black box side of things. Are there questions in the room before I think I've hit the wrong button here. There are questions in the room. You can just shout something out.
On your proofs of concept, how big have the trees gotten? Like, is there 100 items in it, or 1,000, or 10,000?
Oh, no, so that's a fantastic question. The first proof of concept, they decided for scoping reason they were only going to use the top level dependencies. As they've started to look into this, especially for the RTOSs, it's going to be big. And in fact, there are a couple of, I know that someone has tried to write this for one flavor of a Linux kernel, where they've actually been able to show, yeah, listen, we found the way, as we compile it, we can actually generate it. So for the large pieces of software, this is going to be very large. And how many you got? No, I think that's a great question. I'm hazarding, so I'd say on the order of 10,000 components for a modern operating system. But again, that's that order of magnitude. If you want to know more about this scope, the Critical Infrastructure Initiative with Frank Nagel up at Harvard Business School just wrote a report of the first analysis of their attempt to do an open source census. The data is heavily built or heavily sampled on the JavaScript universe because that's where the data was. It was this classic streetlight problem. But that gets us some insight into what these dependency trees look like and where they overlap. I'm getting the stop sign. So please don't hesitate to get in touch. I'll be out in the hallway after this afternoon. And I'll be around San Francisco all week. So please get in touch and join us. We need your help. Thank you.